Before we start, just a quick public service announcement about everyone's favorite candy, that peanut butter cup covered in chocolate. When it's in the cup form, you call it Reese's. When it's in the small bite-sized candy form, for some reason we call it Reese's Pieces. Like, that's not how you say the word pieces. It already rhymed. Reese's Pieces. So yeah, Reese's Pieces is not the correct pronunciation. Okay, we take a sample of Reese's Pieces. What proportion of the candies will be orange? If you haven't had Reese's Pieces, you're probably very confused by my sarcastic public service announcement. I think they're brown, yellow, and orange. They're like M&Ms, but they have peanut butter in them. Suppose a large bag of Reese's Pieces has 1,000 pieces. The manufacturer says that 40% of them are orange. If we select a sample of 50 pieces, how many will be orange? X is going to be the number of orange candies in the sample. So what I'd like you to do first is just question 1. Pause the video and do that on your own. Hint, it's something from the last unit. All right, this is a binomial distribution. We have B for binary. The selected candy is either orange or not orange. I for independent. The candies aren't being selected independently, but the 10% rule is met. If we take n times 10, that's 500, and there are more than 500 pieces in the bag, so that's fine. N, we have a set number of trials. We're taking out 50 pieces. And S, we have the same probability on each trial. 40% is the probability that it's orange. So luckily there is an applet. So you're going to click on this link and let me show you what you should do. First we have to set this up to match our scenario. So the probability of orange in our scenario is 0.4, and we are pulling out 50 candies at once. Now it's initially checked with animate. So if you click draw samples, it's going to animate shuffling around all the pieces, and it'll show you how many orange you get. It's very cute, but it takes a long time. So with this first sample, we get 26. It says to repeat this 5 times and list the values below. So if I were doing this, I would write 26. And then if I were doing it, I would uncheck the animate box, because then I can just quickly draw my samples. So draw your 5 samples and write them down. Here's my 5. Then you're going to click on this Google form, fill it out once for each of your 5 samples. This will take approximately 2 seconds per sample. You can do it. And then when you're done, click here to see the results and do a quick sketch of the dot plot. The number of candies can be found here. So you're just going to copy this and paste it into Statplet. To get the dot plot, when you go to Statplet, do one categorical variable. It's just a single group, and then just paste that data there. Then hit play, and I'll tell you what to do next. So at the time of filming, this is what mine looks like. Everything from 14 to 26, pretty varied. The most was 17, 24, and 25 close behind. Okay, so now I'm going to have you pause the video and answer 4 and 5. Just a quick heads up with number 5. We identified this as a binomial distribution, so for number 5 you can use the formulas for a binomial distribution. Don't type in all the numbers on your calculator or do anything by hand. Just use the formulas. So pause the video, 4 and 5 now. All right, each dot in this dot plot represents the number of orange Reese's Pieces from a single sample of size 50. This is a really important concept I'm going to keep bringing your attention back to throughout the next couple videos. What does each dot represent? Each dot represents one sample of 50, and in this case, it's the number of orange candies in that sample of 50. For the mean and the standard deviation, we're just using the formulas that we learned for binomial distributions. So NP, the expected number of orange candies is 20, and that is represented, at least at the time that I filmed this, although yours is going to look different. Standard deviation 3.46. Now for the shape of the sampling distribution, this is another review of binomial distributions. Pause the video and see if you can answer this one using what you know about binomial. Okay, NP and N1 minus P are both greater than 10. They're 20 and 30 respectively. So the distribution would be approximately normal. So far, everything we've done on this page has been a review of binomial distributions. Okay, so next, instead of looking at the number of orange candies, we're going to think about the proportion of orange candies. Okay, now I updated these directions. At first I was going to have you convert your 5 values into proportions and then put them into a new Google form. And then I was like, that's a waste of time. Instead, I just set up the responses spreadsheet to calculate the proportions for you. So when someone puts 23 into the Google form, this column automatically takes that 23 and divides it by 50. So now let's take this column of proportions, don't do the zeros, obviously, and put that into Statplet and see what that dot plot looks like. Pause the video to do the dot plot and then do 8 and 9 and then hit play. Okay, at the time of filming, this is what my dot plot looked like. You will notice it's the exact same dot plot as before. It's just instead of number of orange, it's all been converted into proportions. The shape is exactly the same. It's just our scale has changed. And once again, each dot represents a single sample, but this time instead of representing the number of orange, each dot represents the proportion of orange from a single sample of size 50. For 10 and 11, I want you to use some previous knowledge to answer these. For 10, find the new mean and standard deviation. Remember in the last unit when we transformed variables, when we multiplied, divided, added, subtracted an entire data set, how did that change the mean and the standard deviation? So that's what I'm getting at with number 10. And with number 11, try to think about how this shape compares to the shape of the original distribution. So pause the video and answer 10 and 11 now. Okay, so we are dividing the entire data set by 50, going through and taking each number and dividing them all by 50. So for means, we just divide the mean by 50, that's easy. 20 over 50 equals 0.4. For the standard deviation, we also are just dividing by 50. Remember, it's adding and subtracting that doesn't change the standard deviation. Multiplying and dividing does change the standard deviation. Okay, so the mean of the sampling distribution of p hat equaled p, which is pretty interesting. The proportion of orange Reese's Pieces in the entire population was just 0.4. So this is always true for the sampling distribution of p hat. The mean of the sampling distribution of p hat, that's how you would read this, equals p. And yes, that means this is an unbiased estimator. Now, if we look at the standard deviation for the sampling distribution of p hat, we took the square root of n times p times 1 minus p to find the standard deviation for x, and then we divided it by 50, which was the sample size. So there's n again. So we could use this as the formula, but there's an n here and here, so we can actually make it a little simpler. The way that my mind works is I'm going to take that n out and I'm going to write it as an exponent, and then I can condense these using exponent rules. This simplifies to just an n to the 1/2 in the denominator, and n to the 1/2 is the same as the square root, so I can just write all of that under the square root. It's okay if those algebra steps don't make sense. This is the formula for the standard deviation of the sampling distribution of p hat. Whew, gosh, that's a lot of talking. And you guessed it, you don't have to memorize these formulas because they're on the formula sheet. So we're no longer in probability, we've gone past that, although we did just we kind of used the binomial formulas here. We're actually on the second page of the formula sheet. Part 3 says sampling distributions and inferential statistics, and over here you can see for one population p hat. Here it gives you the parameters of the sampling distribution. So the mean of p hat equals p, standard deviation p hat is the formula I just wrote down. I'm tired of saying it. Okay, the approximate shape. Well, we saw that the shape didn't change. All we did was convert all those numbers into proportions. The shape is exactly the same. So it's still approximately normal because np and n1 minus p are both greater than or equal to 10. Okay, so now let's do something interesting. We know that a bag of Reese's Pieces contains exactly 40% orange. If we select a random sample of 50 candies, what's the probability that the sample proportion will be 50% or greater? So we're not talking about selecting one Reese's Pieces piece. We're not looking at the probability of selecting one candy and seeing if it's orange. We're looking at a sample of 50. What's the probability that in that sample of 50, the proportion of orange is 50% or greater? So I think it's best to start with a picture. Here's the sampling distribution of p hat. We said that the mean of the sampling distribution was p, so 0.4. The standard deviation was 0.0692, and we're trying to find the probability that p hat is greater than 50%. So step 1, I would say, is do a drawing. Step 2, I always recommend that you write out what you're trying to find in symbols. We're trying to find the probability that p hat is greater than 0.5. I'm not kidding, just writing p hat is enough to remind you, like, oh, I'm dealing with samples of size 50. This is a sampling distribution, not the population distribution. Once we have that written, we've already said that this is normal, so we can start going to the z-score step. I'm going to take 0.5, that's what I'm interested in, minus the mean divided by the standard deviation of the sampling distribution. See, it's important to write p hat there. So I'm using 0.0692. We're finding the probability that z is greater than or equal to 1.45. We go right to the calculator, do norm CDF, and if you want, you could write that as a percent at the end. The probability that you take a sample of 50 and there are more than 50% orange candies in that sample is pretty low. It's only a 7.35% chance that that happens. There are 2 practice problems in these guided notes. We're actually going to skip number 1 because it's very structured. I'll post the answers to it in the description of this video in case you want to do it for extra practice. I highly recommend it. I want to look at number 2 because it's completely open-ended. They just ask a question and say use the 4-step process. So pause the video and read the question for number 2 and then hit play. So with the state plan do conclude process, what this is helping you do is make sure that you have all the conditions met before you do a calculation. The state step is very simple. You just have to restate what you're supposed to find with context. Context is so important in these questions. So we want to find the probability that the sample proportion of middle schoolers who plan to go to college, we'll call it p hat, is between 0.73 and 0.87. Notice that I said of middle schoolers who plan to go to college. You want to make sure that in your state step, it couldn't be just written about any problem in any context. You have to say students going to college, all that stuff. Is that a spider? Hold on. No, I have a thing. I have a thing about spiders. Not my favorite. Anyway, context is important. Okay, next is plan. The first thing you want to do in the plan step is check to see if your distribution is normal. So in this case, we're looking at the sampling distribution of p hat. If it's not normal, we literally have to stop doing the problem because we can't do any norm CDF like z-score calculations if the distribution isn't normal. So sometimes you get to plan and you have to say, this is clearly not a normal distribution, we gotta stop. The sampling distribution of p hat is approximately normal because NP is 100 and N1 minus P is 25. Both of those are greater than 10. Okay, so that means we can continue. The next thing we need to do in the plan step is figure out the mean and the standard deviation of the sampling distribution. The plan step is basically figuring out all the pieces that you will need to do the problem. Did you hear the way I said pieces there? I didn't say pieces, did I? I said pieces. Sorry, maybe that's too shady. Okay, the mean of p hat is 0.8, just equal to p. Standard deviation of p hat, we're using the formula here, p, 1 minus p over n, and then square root, 0.0358. Now, in order to use that formula, we technically need to check the 10% condition. This is something that isn't included on the formula sheet, so it is something that you need to remember. Anytime you're using the standard deviation formula for a sampling distribution, you have to either have independent observations or, since that's unlikely, you need to check the 10% condition. So we're fine here. We have to assume that there are at least 1,250 middle schoolers in the district. In my district, that's true. If it's not true for you, you can pretend this problem is about my district. So check the 10% condition for standard deviation. Then I like to do a little picture. So here's the sampling distribution of p hat, here's the mean, here's what we're trying to find. Probability that we get a p hat between 0.73 and 0.87. So yeah, that's the whole plan step. It's like all the stuff that you want to skip. You want to get right to the calculation, but you can't, because if the distribution isn't normal, you can't use norm CDF. If the 10% condition isn't met, then you can't use the standard deviation formula. There's a lot of steps here, and if you make a specific step where you are planning, you won't miss things. So resist the temptation to go directly to your calculator, find the answer, and circle it. Now when we get to the do step, you can actually calculate the z-scores and plug them into norm CDF. I'm not going to go through that in detail. And then in the conclusion, make sure you include context when you are stating the answer. The probability of getting a sample proportion of middle school students who plan to go to college between 0.73 and 0.87 is 94.95%. There's a really good chance that p hat is between 0.73 and 0.87, which makes sense. That's a very wide range. This is how you should always approach these open-ended probability questions that just say, what's the probability? Previous math classes have probably trained you to see this and think, oh, all I have to do is literally this right here. And then I just put a box around the number and then I'm done. In statistics, that is rarely the case. We want state, plan, do, conclude, and we want context, context, context. As I've said in previous videos, if the normal calculations are throwing you, try going back to Unit 1 and rewatching the normal calculation video. It was towards the end of Unit 1, because we're really building on that here. And if the idea of a sampling distribution is confusing you, go back to the previous video, rewatch that again, or, ask your teacher or ask someone in your class. It's really important that you understand both normal conditions and sampling distributions before any of these things will start to make sense. But we know that the most important thing you learned in this video is that it's pronounced Reese's Pieces. Reese's Pieces. I don't get it. It's okay if you were saying it that way though. We all make mistakes. Now you know.